morning. Today we are flipping the classroom, as in you're going to watch this video for today's notes. Please pause as needed, as well as take down any necessary notes. Please remember I am walking around to answer any of your questions. So here's the answer to 47. It was a proof that I thought some of you may have questions on, so I have completely typed out my answer. Here are the textbook answers to 49 through 53, and then 57 through 60. Again, please feel free to pause this video as needed. Yesterday we talked about triangles, and we talked about the different types of triangles. Well, today we're going to talk about some more about triangles. And today we're talking about the angles of a triangle. So you probably already know this theorem, which is the sum of the angles of the measures. The sum of the measures of the angles in a triangle is always 180 degrees. This is the triangle angle sum theorem. Here is a proof of that theorem. So in order to prove this theorem, what I did first is I drew a parallel line through the vertex opposite the side of the triangle, and I made those two lines parallel. What enabled me to do this is the parallel postulate, which says through any point there is one parallel line. And then I knew that angle 4 and angle BAD are supplementary because they form a linear pair. The textbook does this in 3 steps, as you can see here. Later on we'll do it only in 2. And then I did the angle addition, which is that BAD is formed by angle 2 plus angle 5. You could have done this before you said they were supplementary. It doesn't really matter. But now that I know that they're supplementary, 4 and BAD are supplementary, I can substitute 2 plus 5 in for BAD, and that's substitution. And then I also know that if lines are parallel, the alternate interior angles are congruent. So that means angle 4 is congruent to angle 1, and angle 5 is congruent to angle 3. I then know their measures are equal, and then I can use substitution to, sorry, my cookies interrupted me. I can then use substitution to prove that the measures of the angles add up to be 180. Well, if I look at this diagram, I have angles 1, 2, and 3, which I would consider interior angles because they're on the inside of the triangle, and angle 4 that I would consider the exterior. How do you think 1 and 2 would be related to 4? Take a moment and think about that. When you're done thinking, well, pause this while you think about it. When you're done, come back. Well, how 1 and 2 are related is an exterior angle is equal to the sum of its remote interior angles. So in that drawing we had, 1 and 2 are the remote interior angles of angle 4, meaning they're inside the triangle and away from it. So if I add 1 and 2 together, I get 4. Next I have what's called a corollary. A corollary is a theorem with a proof that comes from another theorem. So it pretty much is because of. So this exterior angle theorem provides us with 2 corollaries along with the triangle angle sum theorem, which says the acute angles of a right triangle are complementary, and there can be at least one right or obtuse angle in a triangle. Write a proof that makes the measure of angle A plus the measure of angle B equal to the measure of angle 1. And I have my proof here. So what I did in order to do this is I named this angle C, and then I'm given that ABC is a triangle. I then know that the measure of angle B plus the measure of angle B and the measure of angle ACB equals 180. I know that angle ACB and angle 1 are a linear pair. I therefore know that ACB plus the measure of angle 1 equals 180 because linear pairs are always supplementary. And then I know that the measure of angle ACB plus angle 1 is equal to the measure of A plus the measure of angle B plus the measure of angle ACB. Substitution, they both equaled 180. I then use the reflexive property that says measure of angle ACB equals the measure of angle ACB. And then I can use subtraction and prove my theorem. So that is the end of today's notes. Tonight's homework is homework page 250, numbers 13 through 29, EOO, 31, 38, 43, 44, and 49.